Watch a normal query pull back its nearest documents, and one of them is restricted. A file this user was never allowed to see. Relevance is not authorization. Welcome to AI Techbook. Today, secure RA. Why? The moment your documents have different owners, retrieval stops being a search problem and becomes a security boundary. Start with the reframe that changes everything. A vector search does exactly one thing. It ranks documents by how similar they are to the query. It does not know who is asking, what team they're on, or what they're cleared to see. Relevance is not authorization. So the moment your corpus holds documents with different access rules, the retriever, left alone, hands the most relevant document to whoever asks, authorized or not. That's what makes retrieval a security boundary. And it means security has to be enforced at retrieval, not hoped for from the model. So where does the permission get lost? It gets lost the moment you embed. When you turn a document into embeddings, most pipelines throw its access rules away. The metadata that said finance only just doesn't come along. Now that vector sits in the store next to everyone else's, indistinguishable, and a similar query from any user can retrieve it. OWASP put a name on this in 2025. LLM0 8 Vector and Embedding Weaknesses. And the leak class it feeds, sensitive information disclosure, climbed to number 2 on their list. So if you don't reattach and enforce permission, the store leaks across users. How do you put the permission back and make it actually filter? You make permission part of the query. 2 moves. 1, carry each document's access rules as retrieval metadata and apply the authorization filter as part of the search, a pre-filter to the user's scope. Not overfetch everything and discard later. Filter first, rank second. 2, the clean way. If your vectors live in Postgres with pgvector, row-level security decides which rows a user is even allowed to select. So authorization and similarity run in the same query path, and every retrieval automatically excludes rows the user can't access. The user can only ever see their own slice, and when it's not one user, but many customers in one store. Then you isolate tenants. Mix every customer's vectors in one shared index, and a query from one tenant can surface another tenant's documents, so you partition. Namespaces give each tenant its own section of the store. Per-tenant shards keep each tenant's data physically separate. And separate indexes, one store per customer, are the strongest isolation of all. Pick the level that matches your blast radius tolerance, because a shared index is a shared blast radius. But what if the danger is inside a document you did authorize? Even a perfectly authorized document can attack you if someone planted instructions inside it. Direct injection is when the user is the attacker. Indirect injection is when the user is trusted, but a document in your corpus carries the attack. OWASP scenario is exact. An attacker modifies a document in the repository your RAG reads. When a query returns it, the malicious instructions alter the model's output. The payload travels the data path, not the prompt. So treat every retrieved chunk as untrusted input, data the model quotes, never instructions it obeys. And what if the attacker doesn't change a document, but adds a few? How few poisoned documents does it take to hijack a giant knowledge base? Fewer than you'd believe. In the poisoned RAG study, an attacker who injects about 5 crafted documents per target question into a base of 1 million reaches roughly a 90% attack success rate. 5 documents, and the model returns the answer the attacker chose. The defenses they tested weren't enough to stop it. Which means the integrity of your corpus is part of your security perimeter. Control who can write to it, not just who can read it. So what do you do at ingestion and after? 2 controls bracket the pipeline. Going in, classify and redact sensitive data before you generate embeddings, because an embedding encodes its source, and once it's indexed, it's hard to pull back. And watch the trap. Encrypting the store at rest does nothing to stop an authorized query from retrieving sensitive content. Redaction and retrieval time authorization are the real controls. Coming out, log every retrieval, who asked, what was returned, when, append only, and export it to your security tooling. That audit trail is what turns RAG into a security product with an LLM inside. But isn't the model smart enough to just refuse to leak? The model layer helps, but it's never enough. even a hardened model still lets about 1% of attacks through, and no agent is immune. So the durable control is least privilege. Applied to retrieval, filter every search to the user's authorized scope, isolate your tenants, treat every retrieved document as untrusted, and redact and log. Secure RAG isn't a smarter model. It's a retrieval layer that enforces who is allowed to see what. The whole thing, one screen. Relevance is not authorization. Once documents have different owners, retrieval is a security boundary. Filter every search to the user scope. Row-level security does it in one path. Isolate your tenants. Treat the corpus as untrusted. It can be injected or poisoned. And redact before you embed. Log every retrieval and keep least privilege at retrieval. That's secure RAG, retrieval as a security boundary. If this sharpened how you think about RAG, share it with one person shipping retrieval. Subscribe to AI Tech Book, one architecture concept every episode. Thanks for building with us.